Okay guys, welcome back to my YouTube channel. Here we will be working on the ORB feature descriptor. ORB is oriented, fast and rotated brief feature descriptor methodology, or let's say techniques. It is fast, free and efficient alternative to both SIFT and SURF. It combines both fast corner dictator with brief binary descriptors, but add rotation and scale invariances. One of the major strengths of ORB, that is oriented, fast and rotated brief, is that it is very fast, low in memory utilization, ideal for real-time application like SLAM in robotics. Open source, there's no patent restriction to ORB, unlike our SIFT. But the major weaknesses that ORB is having is that it's less distinctive than SIFT and ORB. It is very less distinctive, and there can be a mismatch. So it does not, unlike the SIFT and SURF that are very distinctive, they are very straightforward in what they are producing. It is less distinctive, thereby producing more mismatch in cluster syncs. Without wasting much of your time, let's dive straight into business of how this is. The first thing we do, we import our image in a grayscale format. The reason for we converting our image to grayscale is because most feature dictators, they work on single channel intensity image, not a colored image like our RGB or BGRs. That's the main reason for converting our image into an RGB. Now let's import the image we are using for this data. ORB image is CV2 dot, okay, we want to convert to RGB, CVT color, then we have our CV2 image, then we convert to RGB, CV2 dot color BGR to R to grayscale. That's the first. So we need the version in RGB so that we use it comparing our final result. So here we say RGB. Great. So now there's a problem. Module CV2 has no attribute CVT color. So there's a problem here. The problem is this C. It should be small letter. Yes, it's correct. Let's correct for the second one. Great. So we are good to go. We've imported our image in RGB and grayscale format. Now we want to create a SIFT and we want to create a ORB features. To create that, we say ORB is equals to CV2.orb underscore create, right? Then n features is equals to 1000. By the way, ORB stands for oriented, fast and rotated brief. It is a fast, efficient and free with no patent alternative to SIFT and SURF, as I've said earlier. So we are actually using a feature of 1000, n feature of 1000, meaning that we will try to find up to 1000 strong key points or corners, edges, texture in a particular image. This number can be tuned, so it can be tuned to 2000 depending on the size of image you're having or the needs for what you are doing. So next we will be dictating key points and computing descriptors. So key points, descriptors is equals to ORB that we've created already, detect and compute. So the image you're bringing in is RGB ORB up, the one in grayscale. Great. So we are, then we set this to none. Great. If you want to put the number of key points now, we could point it out, but we don't necessarily need it. So key points here actually dictates our interest points in an image, like blobs, corners, some features or patterns. While the compute descriptors is, it's made up of small numerical vectors that describe the appearance of how each point appears. Vectors could be in x and y axis or any pattern it exists. Then the result of the key point is actually a list. The CV2.keypoint itself is an object. Descriptor is a numerical array, on the other hand, of features, usually in 32 bits per key point. So next we'll draw the key point on the image. We're doing key point on the image now. To do that, we'll bring in our ORB image CV2.draw key point. We've actually be able to dictate the patterns already. Now we are trying to paste the pattern on a plain image. So we key point none, then flags CV2.this draw match. Now we'll be able to draw circular areas. It's not correct, so key point is key points with S. So they're easy to debug, that's the funniest thing. Great, exactly. So now the key point CV2.key point draw a particular circle orientation on the indicated points in an image. While flag itself here, I think is the only one I've not explained. Flag makes visualization very rich, making sure that the locations of the key points and the size and the directions of the features are visible to see and more clearer. So from here now, what we've had now, the result of our feature So now from here, we'll be able to have our image of ORB detector using feature descriptor in computer vision. Let's view our image. Let's view our results. So we'll be comparing both the feature mapped or feature descriptors experimented version, which is in ORB, and the original version. So to do that, let's go to figure, let's go to ground for it, then fix size 12 by 6. So let's go to subplot to be able to have the two image by side by side. 1, 2, 1 is just one image I'm creating. Plt dot im show. So this is not the original, this is the original version in RGB. Then plt dot title. Let's just give it original image or version. Then plt dot, let's off our axis because we're not doing a mathematical calculation or something. Make sure the O is capital letter O, of the capital letter of O is, yeah. Then plt dot subplot for the next, that's 1, 2, 2. We have plt dot in show, which we would be bringing in our experimented image. Next, we have plt dot title. Here we would have ORB version. Plt dot, let's of our axis as well because we don't display the images. So you see the display guide label, but it will give some functions. Now from here we'll be able to see that we add our pictured map on each other, but there's a problem with the original image. Let's check what the problem is. It is great. If you look at the image here, we bring it in an RGB, but we do not. It's very important we make sure it is RGB. That's where major problems come from. Exactly. So this is one of the powerful functionalities of feature descriptors. Hey, there's a problem here. Let's see. There is a problem here. There is a problem here. Okay, this is where it is. This is where it is. The image we need there is the RGB original image, not the grayscale, because it's the one that helps us actually dictating and mapping the point. Then, okay, let's see our result now. Our result should be fine by now. Great. So this is what our original image is expected to be. This is our result. So from here, we've been able to see the power of ORB as a feature descriptor, helping us to actually identify points where intensity changes in an image, but it is not as effective as SIFT because it's actually like generalize a whole region. It is not as effective as SIFT that pinpoint a distinctive location. Thank you very much for sticking with us. Next, we'll be doing the final section, which is histogram descriptor, feature descriptor.